Good afternoon, everyone. How are you doing? Hello, Nena. Good afternoon. How is everyone doing today? How is everyone doing today? Everyone doing well? How are you all doing? I hope you've had a good week so far. I'm looking forward to spending the hour with you. Can you all hear me? Okay. I just wanted to be sure. So good afternoon, everyone. Thank you for joining us today. Today we're going to be looking at different topics for most likely for students that are in towards the end of the middle school all the way to the end of high school. So we have some SAT questions today, as well as some ACT questions that we can also use to learn. So like we would normally do, I'm going to have the question out here, and then I'll give everyone a chance to try to answer it, and then we'll try to answer it together. And if you have questions along the way, you can ask them, and then I will definitely make sure that I can create time to answer as many of your questions as possible. Are we ready? Hey Cheryl, Nena, Ogechuku, good afternoon to all of you. Thank you for joining us today. Okay, so we're going to try our first question for today. And always remember that along the way, you can stop me or you can ask questions, and then I'll make sure that I address all your questions. So let's go ahead and start with today's questions. So we want to find out the equation of a line that passes through these 2 points. What is the equation of a line that passes through these 2 points? What is the equation of a line that passes through these 2 points? This actually is more of a, it's for students that are in 8th grade Algebra 1. This is when you start to see this type of questions. 8th grade or 9th grade, you'll start to see this type of questions. And so let's see if you can, if you're not sure what to do, also let me know and I'll walk you through every step and the easiest steps that you need to follow to make sure you can do this on your own independently or do this on your own in the future. So what is the equation of a line that passes through the points -5, 8 and 3, 2? So we're going to start with, I'm going to give you a hint, just something that I want you to take note of. This is what you need. Y minus y1 equal to mx minus x1. Okay, I see some are not sure what to do, so that's okay. That's why we're here. I'm going to help you understand exactly what you need to do to answer this type of questions. So does anybody know what to do with this type of question? Okay, let's go ahead and I'll show you exactly how you need to go about this. And if you have any questions as we walk through the problems, please let me know and I will definitely address your questions. So here's what we're going to do. This is our formula, y minus y1 equal to mx minus x1. Here, m here is the slope. So you have to first find the slope of the line that connects these 2 points together. So we're going to look for the slope. To find the slope, we have slope is going to be y2 minus y1 over x2 minus x1. When you have points, your points represent the x value. Every point has an x value and a y value. So in this case, what we're trying to say is we have the y1 and y2, x1 and x2 to know is just for a reference. So what we're going to do here is we're going to have this one because every point is written in the form x, y. So this is going to be our x1 to show that it's the first point. And then this is our y1. This is our x2. And this is our y2. So now we can use this information to get the slope of the line that joins these 2 points. So now we're going to substitute these values in and we're going to have y2 is 2, so we have 2 minus y1 is 8 divided by x2 is 3 and then x1 is minus and then we have -5. So 2 minus 8 is going to give us 6 and the reason why you have that is you have the signs are different, so you're going to subtract the number. So 8 minus 2 is 6. And then we're going to use the sign to the left of the larger number or the greater number. So you can see here is greater than 2. And if you look to the left, you have a negative sign. So it's going to be a -6 divided by, when you have a negative and when you have a sign, you have parentheses and another sign, you simply we'll just multiply this together and that's going to give you a plus here because negative multiplied by negative is positive. So this is going to be 3 plus 5. So this is going to be -6 divided by 8. And now we can simplify this fraction by dividing by 2. We divide this by 2. -6 divided by 2 is going to give you -3. And then 8 divided by 2 is 4. So now we have the value of our slope, which is going to be -3 over 4. Now we need to go ahead and get the value of y1 and x1. We can just use this right here. We have x1 and y1 here. So now we're going to take all of those pieces of information and we will substitute into this equation. So now we have y minus y1 is 8. Y minus 8 is equal to m is -3 over 4, which is our slope, -3 over 4, multiplied by x, and then minus x1 is -5. So now we're going to simplify. Whenever you're dealing with math, always remember PEMDAS. All right, Anastasia, very good. Well, I think you made a slight mistake, but I'm sure I'll show it to you. Look in your parentheses and see if you can see your error. So we have y minus 8 equal to negative 3 over 4, and we have x. Here we have negative, so it's going to be plus 5. So you can leave it as this. It depends on the way the question is asked. You can leave it as this, or you can further simplify. Some questions will tell you to write it in the form y equal to mx plus b. Other questions may ask you to write it in the form ax plus by plus c equal to 0. So it all depends on the way the question is. This is correct. This is the correct answer. We can go further. And we have y minus 8 equal to negative 3 over 4 x minus 5 multiplied by negative 3 over 4. So 5 multiplied by negative 3 over 4. So this is going to be minus 15 over 4. So this is where you can end here, but we can also add 8 to both sides here and add 8 to both sides. Now, your knowledge of fractions is going to be really important. You have to remember how to add and subtract fractions for this to work. So you have negative 15 over 4 plus 8. What we're going to do with 8 is we're going to write it as a fraction with a denominator of 1. So we're going to make that 8 over 1. And now that you have different denominators, you have to go ahead and make sure that you have two fractions with the same denominator. So here I have 4 and 1. All I need to do here is multiply 1 by 4 and multiply 8 by 4. So I now have negative 15 over 4 plus 32 over 4. So now that we have the same denominators, we can just simply add the numerators. So we have 4 here and we have negative 15 plus 32. And here we're just simply saying 32 minus 15. That's going to give you 17 over 4. So now our actual equation, the final equation would be y minus 8 equal to negative 3, sorry, not minus 8 because we already moved the 8 off. So it's y is equal to negative 3 over 4 x plus 17 over 4. So that's what's going to be for this equation. So this is going to be the equation of the line that passes through those 2 points. Are there any questions? Any questions on this topic? Would you like us to do another example? If you want us to do another example, I'm game for that as well. Would anyone like another example? Okay, if you have any questions as we continue, just post them in the chat. Okay, you would like another example? Okay, let's go for another example. Let's go for equation of a line. Let's go with equation of a line that joins 4, 3 and 2, 0. Let's do that. Actually, let me use 2, 2. Make it. So let's make it 2, 2. So the first thing we're going to do, remember, is we always start with our equation because you need to know what you're trying to arrive at. The equation here is going to be y minus y1 equal to mx minus x1. And our m is the slope. And don't forget, your m is going to be y2 minus y1 over x2 minus x1. So now that we have these two equations, what we're going to do next is go ahead and figure out what x1, y1, x2, y2 are going to be. So we can pick any points. So let's go with this one here. Let's go with x1, and then this is y1, this is x2, and this is y2. So now we're going to plug these values into our equation here. So this is going to be, y2 is going to be 2 minus y1 minus 3 divided by x2 is also 2, and then x1 is 4 minus 4. So this is going to be 2 minus 3 is -1, and the rule is the same. When you have two numbers with different signs, if you don't have any sign to the left of a number, you can say it's positive. You can safely say it's positive. So we have a positive and negative. So what we're going to do is subtract the numbers, which gives us 1, and then we'll use the sign to the left of the bigger number. So we're going to do that here, and we have -1 divided by -2, which is going to give us 1 over 2. Okay, so now we have our slope, we have our x1, we have our y1. So now I'm going to write this equation out here again so we can see what we're working with. Y minus y1 is equal to slope x minus x1. So now we're going to have y, what is our y1? Our y1 is 3, so y minus 3 is equal to our slope, which is 1/2, and then we have x minus 4. So this is the first part of our equation, all right? Okay, all right, that's good, Ogechukwu, good. And so now that we have that, we're going to simplify, and we have y minus 3 is equal to -1/2 x, sorry, it's 1/2 x rather. It's 1/2 x, and then 1/2 multiplied by -4 is going to be -2. So now we can add 3 to both sides of this equation, and we have y is equal to 1/2 x plus 1. And that's going to be this is going to be the equation of the line that joins these 2 points together. Is this clearer? Does it make more sense to you all? Okay, so if you want more examples, we also have a video on our channel that actually goes through a greater level of detail with several examples. So that's also some place that you can get some more information. So this is clearer to everyone? Okay, that's good. Okay, the next thing we're going to do here is absolute value inequalities. So this is something you're going to see most likely you're going to see this in Algebra 1 and Algebra 2. Some schools may do this in grade 8, but I think it's more an Algebra 1, Algebra 2 topic. So what we're going to do here is we're going to solve for x. We have an absolute value, 2x minus 1 greater than 5. So we're going to use this information to get all the values of x. Remember that when you're dealing with inequalities, you're looking at a range of values. So you're not looking for just one answer or two answers. You're looking for a range of values. So I'll give you some time to try. I'm going to show you 2 different ways of doing this. One way may be easier for you than the other way, but I want to expose you to at least 2 different ways. And I'll show you the one that I think is the easiest to work with as you go through your math classes. So this, if you're here in our summer program, if you're in the Algebra 2 program, this is something that we're currently doing. So this is also another opportunity for us to review those topics. Okay, x less than equal to 3. Is it less than or greater than equal to? Okay, so I see one response. Let's keep going. Let's see if we have more people that are trying to solve this question. I'll give you a few more, probably about 30 more seconds to see if we come up with a different answer, and then I'll show you exactly how to go about this. I'll show you 2 different methods to go about this. Also, if you're getting ready for the SAT or the ACT, this is a very common type of topic, type of question that you will see on the SAT or ACT. Actually, I modified an existing SAT question to make this one. So the only difference between what I have here and what you will see on the SAT is I don't have any answer choices. So I want you all to try this. If you're taking the SAT, ACT, don't forget that this is an important topic for you to know. So I see some, okay, I see some answers here. All right. Okay, so it looks like everyone is making a good attempt at this question. So let's go ahead and show you the two methods. I'm going to show you the one method that I think is the easier method to use, and then we'll do the one that I think is a bit more tedious. But the first one is the one I would recommend you use every time. So let's go with the first method. So what we're going to do here is I have my absolute value of 2x minus 1 is greater than equal to 5. So what we're going to do now is have 2x minus 1 greater than equal to 5. And then we'll keep our, we're going to keep our inequality symbol, which is greater than equal to here. And then we're going to change this sign, the number from 5 to -5. So this is I found to be the easiest one to remember when you're dealing with absolute values, because you have to always account for two scenarios, and this already does that for you. So now that we have this, we're going to go ahead and solve this expression, this inequality here. We're going to go ahead and add 1 to every part of the inequality. We add 1 to every part. So now we have -4 greater than equal to 2, which is greater than equal to 6. Sorry, it's 2x. And greater than equal to 6. Now that we have 2x, we need to remember it says solve for x, so we need to isolate x. So let's go ahead and divide by 2 on all the sides. Divide by 2. So now we have -2 is greater than equal to x, which is greater than equal to 3. So now we have to look at what does this mean. So you're saying -2 is greater than equal to x. If -2 is greater than equal to x, it means that x, in that case, is less than equal to -2. And here you have x is greater than equal to 3. Now for this method, this part of it ends up becoming the most challenging part of this method, because you have to be able to interpret what the inequality means. So now that we've done this method, I'll show you a different method. In that method, you don't have to do all this work with interpreting the inequality at the end. So let me show you what that one looks like. We're going to account for two instances, because whenever you're dealing with absolute values, you're taking note of the fact that the expression could be a positive or a negative expression. So we're going to work with both. So let's start with the positive expression. So plus 2x minus 1 is greater than equal to 5. So now we're going to solve for that. So now that we're just going to take this out, because plus here just simply means +1. So we have 2x minus 1 greater than equal to 5. Let's add 1 to both sides, and we have 2x is greater than equal to 6. And then we're going to divide by 2, and we have x greater than equal to 3. So you can see that we ended up at this point as well. Now the second thing we need to remember when you're dealing with inequalities is absolute value inequalities, is that you can also have a negative value. So that's going to be written this way: -2x minus 1 is greater than equal to 5. Now we're going to distribute the negative into the parentheses, and you have -2x plus 1 is greater than equal to 5. And then we're going to subtract 1 from both sides, and you have -2x is greater than equal to 4. Now that you have that, we need to isolate x. Remember, we're solving for x. So we're going to divide both sides by -2. Divide both sides by -2. And now what do we have? We have x here, and we have here, we have -2. But here's something that you have to remember. Whenever you are dividing or multiplying by a negative number, you have to flip the symbol, the inequality symbol, and you're going to have less than equal to -2. So you can see that here we get to the same answers. Now, the only thing I know that could be challenging for students is this interpretation. Once you can handle this interpretation, you can see that this is a quicker method to use. This one takes a little bit more time, but you don't have to worry about any interpretation at the end. So that's why those are the two different methods you like to use. I would say I prefer to use this one, and I would recommend you use that. But if you have problems with interpretation when you get to this point, then I would say go ahead and use this method. You can see that regardless of the method you use, you always end up with the same answer. So when you divide by a negative, when you divide by a negative or you multiply by a negative, you always have to flip the sign. Always have to flip the sign. Well, that's a good question. Okay, so let's go to, are there any questions? Did everyone get the two methods? I mean, you can use them interchangeably. I use both of them. It depends on what type of question I'm working with. Okay, let's go to the next question, and then after that, we're going to have our first puzzle for today. All right, we're going to solve for x. This actually came out of our SAT exam. The square root of x plus 4 is equal to 12. What is the value of x? So what I've tried to do today is try to see if I can bring in some SAT questions, some ACT questions that are relevant to the 8th to 12th grade classes. Okay, let's see if we're able to answer this question. So we're looking for the value of x. Square root of x plus 4 equal to 12. We want to find out the value of x. Always remember, whenever you have equations, you're looking to isolate a variable. So let me just make a note there. Whenever you have an equation, look to isolate a variable. Isolate the variable. So we're going to isolate the variable. That is the key to answering this question. We need to isolate the variable. 2 square root of 2. Okay, that's one answer. So let's see if we have some more answers. Thank you for trying to answer the question. Okay, anybody else have an idea of how we can go about this? Remember, isolate the variable. When we say isolate the variable, it simply means make sure that the variable stays by itself on one side of the equation. So anything that is not a variable needs to move off of that side. If it's a constant, it needs to go to the side with all constants. What is a constant? It's just a number. So all numbers go to one side, all variables stay on one side. That's the key to answering this question. So I've given you a hint, isolate the variable. 2 square root of 2. Okay. So you could go a different method, but I think that method will lead you to a far place that it will take so much longer to do. And I don't think it's a good way to spend your time doing this question. So let me show you the first step. The first step in isolating the variable is to move. So the first step is to isolate the variable. And to do that, we're going to move all the numbers away from the side of the variable. So here, our variable here is x. So let's look, I'll put this in parentheses, x. So we're isolating the variable x, and to do that, we're going to subtract 4 from both sides. Okay? So now we are left with the square root of x is equal to 8. So now that you have this, you still have some more work to do to isolate the variable. When we say isolate the variable, it means x is by itself. There's no square root, there's no exponent, there's no negative sign. It's just x by itself. So now you have to ask yourself, what do I need to do with square root of x to make it x? That's the next part of the question. So now all of this, you can see it's all about isolating the variable. We're taking different steps to isolate the variable. Now we have square root of x is equal to 8. Now you could probably guess, oh, what is that number I multiply by? What is the number that if 8 multiplies itself, what do you get? Now that's one way to look at it, but here's the best way to understand this. We need to remember that x multiplied by x is x squared, and then also the square root of x multiplied by the square root of x is going to give you x. Okay, so now we're going to simply do this. We're going to square this. Whenever you have a square root, in order to remove it, you square the term or the variable. And because you squared this right here, you're also going to square this. Now let me just give another example. If I had something like this, the cube root of x is equal to 4. Now you're going to pay attention to the root on this variable. In this case, the root is going to be 3. So in order to isolate x, you're actually going to cube this. And whatever you do on the left-hand side, you do on the right-hand side. So that's correct, Anastasia. So this is what you're going to do this is a very common type of question on your SATs, on your ACTs. Please pay attention to the method the method and the approach that I'm using to actually answer this question. So here, now that we have the square root of x squared, that's going to give us x. And then 8 squared is 64. So this is going to be the answer to this question. Now let's see, are we actually right? We can actually go back and check if the answer or the approach we have taken is the right approach. So let's go ahead and make x equal to 64. The square root of 64 plus 4 is going to give you 8 plus 4, which is 12. So this is another way you could, if you're taking an exam and you want an opportunity to go ahead and check your answer to see if your answer is correct, this is what you can do. So you can see that our answer is correct because when we make x or substitute x equal to 64 in the left hand side of the equation, we get the value on the right hand side. So that's that. Any questions? Are there any questions? Do let me know if you have questions as we continue. Okay, so let's go with our first puzzle for today. So 5 girls participated in a race. Maria finished before Sarah but behind Ella. Marianne finished before Julia but behind Sarah. In what order did the girls finish the race? In what order did the girls finish the race? Yeah, for those who are regular in our sessions, you know, typically you would see my camera, you see my face, but camera is having an issue today and I didn't want to cancel the session. So just be patient. Next, I have a solution for it. I just couldn't do it before the session. So please be patient with us as we walk through this issue. This shouldn't happen again. So but continue participating, you know, let the answers keep coming through. And the most important thing is I did not want to cancel the session today because I wanted to make sure that those who were really expecting this session would not be disappointed. So thank you for your patience and always, you know, adjusting to any unforeseen circumstances. So thank you. And remember, this is really your time. So if you have any questions about anything that is math related, or that whether something you may be studying on your own. I know some students are preparing for the SAT or the ACT. You may be studying on your own and you come across a question that you're not sure how to answer. Please feel free to bring them here. This is the forum that we'll call it our safe space to learn math without any judgments or anyone making fun of you. So feel free to do that. All right. So I see Ella, Maria, Sarah, Miriam, Julia. Okay. Everyone seems to think the same. Ella, Maria, Sarah, Miriam, Julia. Okay. That's very good. So let's go ahead, since we have some answers already, let's go ahead and see if we all agree. So 5 girls participated in a race. Maria finished before Sarah. So what I'm going to do, I'm just going to have some letters. So let's call Maria is going to be M and Sarah is going to be S. This is not any order, this is not the order. Sarah is S, Ella is going to be E, and then we have Julia, J for Julia, and then we have Marianne. I'm just going to make this M-E for Marianne. Okay, so now let's go ahead and see how, all right, I see some more answers coming through. That's good. Thank you for your response. I really appreciate that. So Maria finished before Sarah. So I'm going to just start from the middle right here. Maria finished before Sarah. So this is going to be first and then all the way to the last here. So Maria finishes before Sarah, but behind Ella. So Ella comes before Maria. Marianne finished before Julia, but behind Sarah. So Marianne finished before Sarah Marianne finished after Sarah, but before Julia. So you should have Ella, Maria, Sarah, Marianne, Julia. Fantastic. Good job, everyone. Good job. Everyone seemed to get this one right. Okay, that was good. And let's go to the next question. Okay. So this is going to be our fraction. I'm going to show you the simplest way to answer this question, but I want you all to try to answer. There's a very simple way to answer this question. I'm going to show you that. And the method I'm going to show you is for those that don't like fractions. If you don't like fractions, I'm going to show you how to avoid fractions when you have this type of problems. So you're going to see a topic like this most likely from anywhere from Algebra 1. You should start seeing questions like this. You may actually see it in some school districts in 8th grade. So I thought about this question because I saw a question similar to this, and I noticed students were struggling with it in some other place I was kind of observing. And I wanted to make sure that we get a chance to actually answer a question like this. Don't forget, this question is also very common on the SAT and on the ACT. So for those of you that are preparing for the SAT or the ACT, this is a very good opportunity for you. Feel free to answer. Don't feel bad if your answer is wrong. I want you to at least attempt it, and you just never know. You may be right. Some may actually end up using fractions. I'm going to show you a different method. Can you solve it, please? Okay, that seems to be what we want to do. Okay, so let's go ahead and solve this together. What we're going to do first, there are two methods to do this. The first method is tedious because it's a lot of fractions, and I know from experience that most students don't like to work with fractions that often. So what we're going to do here is we're going to find the least common multiple of all the numbers in the denominator. So we need to find, so let's go first step here. We need to find the least common denominator of 5, 3, 10, and 15. So what we're saying here is we need to find that number that is a common multiple, is the first number that is a common multiple of all these four numbers. So can anyone think of the least common denominator of 5, 3, 10, and 15? Anyone think of the least common denominator of 5, 3, 10, and 15? Okay, we have 30. Always remember that your least common denominator has to be at least the highest number or more. It has to be greater than or equal to the largest number in your set. You can't have it less than, I think what you probably did was a factor, not a multiple. A multiple means a multiplying factor. So you're actually multiplying. You're multiplying while a factor means you're dividing. So that's the difference. You have to remember that. So let me show you how to actually get the least common denominator or the least common multiple of a set of numbers. So what I'm going to do here is we have 5. There are two methods. The one method I don't like too much because it's too long. One of them, the first method, is to list all the multiples of 5, all the multiples of 3, 10, and 15 until you get to a common multiple. That takes too much time. So what we're going to do here is I'm going to write 5 as 5 to the power of 1. 3 is 3 to the power of 1. 10 is 2 to the power of 1 multiplied by 5 to the power of 1. And then 15 is 3 to the power of 1 multiplied by 5 to the power of 1. So now that we have all of this, we're going to look for every unique factor. Every unique factor. For those that are not sure, this is from a factor tree. So we're going to look for every unique factor. So that's LCD. Every unique factor, we have 2, we have 3, and we have 5. And then we're going to look for the largest exponent. In this case, all of them have an exponent of 1, so you don't have to worry about that. So you have 2, 3, 5. So now this is going to be 2 multiplied by 3, 6 multiplied by 5, 30. So 30 is correct. That is the correct LCD in this case. Now what we're going to do is, in order to get rid of our fractions, we're going to multiply every single fraction here by 30. So we can get rid of the denominators. So now we're going to have, let's take it one at a time. We have 3x over 5 multiplied by 30. We can divide 5 by itself, 1, and 30 by 5, we have 6. So this is going to give us 18x. So you can see now that we don't have a fraction. Now we have 2x over 3 multiplied by 30. We can divide 3 by itself, and then 30 by 3, we get 10. This is going to be 20x. Then we have x over 10. We multiply that by 30. We can see here that 10 divided by itself, 1. 30 divided by 10, we have 3. So this is going to give us 3x. And then 14 over 15, we multiply that by 30. Here we can divide by 5. We get 3. We divide by 5 here, we get 6. And then we can divide by 3, and 6 by 3, we have 2. So this is 28. So now instead of these fractions, we're going to replace that with these numbers here. So we have 18x plus 20x equal to 3x plus 28. So now we're going to group common terms together and simplify. So 18x plus 20x is going to give us 38x equal to 3x plus 28. So now we're going to isolate the variable. You know, like I said earlier, whenever you're working with equations, the goal is to isolate the variable. So I have 38x on the other side. On the left hand side, I have 3x on the right hand side. I'm just simply going to subtract 3x. So that gives me a chance to have all the x's on one side. So 38 minus 3, we have 35x equal to 28. Now we're not done isolating. The next thing we're going to do here is to divide both sides by the number to the left of x, or of your variable. That number is also known as your coefficient. So you're going to divide both sides by 35. Divide both sides by 35. Now we can try to see if we can simplify the fractions. So this is going to cancel out. So we can divide 28 by 7. So let's have it here. X is equal to 28 over 35. We can divide 28 by 7 and divide 35 by 7, which is going to give us x equal to 4 over 5. So that is the value of x in this equation. Does it make sense to everyone? Okay, good. Cheryl, x is equal to 4 over 5. That is very true. So you can see here that if you don't like fractions, this is the easiest way to go about it. If you love fractions, you can work with it the way it is. You may end up still doing something similar at the end, but this is a method that would work for you all the time. It's actually less prone to error. You make less mistakes doing it in this method because you don't have to worry about all the fractions. Because if you look at this question, the way it's set up, you have to do fractions on the left hand side, you have to do fractions on the right hand side, and you know it's easy to make mistakes when you're doing some fraction. So this method will make it a lot easier for you. You still don't get how I got 30. So what you're looking for is, you're looking for a number that is a multiple of all of these numbers, but you're looking for the smallest one. So I'll show you something here. You have the long method is to list all the multiples of each of these numbers. So for 5, you would list 5, 10, 15, 20, 25, 30, and you keep going. For 3, you're going to do the same thing. You're going to list all the multiples of 3 and until you get to 30. Here for 10, you have 10, 20, 30. And then you get to 15 and you have 15, 30. You can see here that 30, 30, 30, 30. So this is a common multiple for all of these numbers, and that's why it is your multiple. Now the other method that I use here, that method is long because if you have much bigger numbers, you will get lost in it. Now this method here, I have a video on it actually that just focuses on finding the least common denominator of a whole set of numbers using the factor trees. So here, what we're looking for is we're going to express each of these numbers as exponents. So 5 is the same as 5 to the power of 1. 3 is the same as 3 to the power of 1. 10 is 2 multiplied by 5, so the exponent is 1 on each of them. And 15 is 3 multiplied by 5, so that's your exponent. Now, what we need to do is, when we want to find the least common denominator, this is a method. What you will do is you will take out every unique factor. So this is a unique factor here. Let me use a different color. So we have a unique factor here. We have one right here. We have another one right here. So we have 5 here, but we already know that 5 is on our list. We have 3, but it's already on our list. And then we have 5. So now we just write the 2, 3, and 5. Then the next step after that is to go look for the highest exponent of each of those factors. This one is pretty simple because The highest exponent in each case is 1. And so we're simply saying 2 to the power of 1 multiplied by 3 to the power of 1 multiplied by 5 to the power of 1. And that's just going to give us 2 multiplied by 3 multiplied by 5. And that is going to give you 30. You know, because you're asking, let's do another example. I know I have some other questions here, but I want to make sure you understand this. Let me actually do another example on LCD. So let's find the least common denominator or the least common multiple, because it's not a fraction. Let's find the least common multiple of 12, 16, 20. Okay, so let's go ahead and use this as a good example for explaining it a bit further. So what we're going to do is we have to express each of these in terms of its prime factors. So we start with 12, we're going to have 2 and 6, then 6, we have 2 and 3. So 12 is going to be 2 to the power of 2 multiplied by 3. Let's go with 16. 16 we have 2 and 8. 8 we have 2 and 4. 4 we have 2 and 2. So 16 is going to give us 2 to the power of 4. And then let's go for 20. 20 we have 2 and 10, and then we have 2 and 5. So 20 here is going to give us 2 to the power of 2 multiplied by 5 to the power of 1. This is 3 to the power of 1. Now our LCM, what we're going to do now for the LCM is look at all the unique factors. We got 2 here. We got 2. So those are unique factors. So LCM, and then we got 3, and then we got 5. So now our LCM is going to have 2, 3, and 5. Now, for each of these, we're going to find the highest exponent of each of these factors. I have 2 to the power of 2, 2 to the power of 4, and 2 to the power of 2. So because we're looking for the highest exponent, I'm going to put a 4 right here. 3, we only have one instance of that, so that's 3 to the power of 1. 5, we have only one instance, 5 to the power of 1. So we're going to multiply these numbers together. We have 2 to the power of 4. We can see here that that is 16. 16 multiplied by 3 multiplied by 5. 16 multiplied by 3, that should give you 48. 48 multiplied by 5, we can see here 0. So this is going to be 20 plus 4, 24. So this is going to give us 240. That's going to be our LCM. So the other way you could have done is, can you imagine having to list every single multiple of 12 until you got to 240, every single multiple of 16 until you got to 240, and every single multiple of 20 until you got to 240. That's the other method. This method I find to be a lot shorter to work with. Okay, so that's that. So what I'm going to do now is I'm going to do our last puzzle for the day. Although I had some other questions, but let's do our last puzzle for the day. And I think that should be a good place for us to stop. So let's get our last puzzle for today. We're going to unscramble the letters to form a word and determine what the 4 words have in common. So all these 4 words are related to the same thing. So we need to unscramble these words and figure out what these words have in common. So you guys have at it. I always know that this is the one area that you guys always surprise me for sure. You guys think outside the box a lot and you do very well at that. So let's go. So just as a reminder to you all, the LCM, we have these topics on our YouTube channel. There's a link there to the playlist that has everything, every type of way you can walk through LCM and apply them. Don't forget that the LCM LCD topic, I think it's most likely a 6th grade or a 7th grade topic. So if you need some help with refreshing your memory or your knowledge on this topic, go to that link. And you can also check, we have created playlists for different topics, so you can, if you have questions about specific topics, you can go there and actually use that as an opportunity to refresh your memory and also see different ways that the topics those concepts can be applied. So I encourage you, use our channel as a resource for your learning as well. And every topic that we have during these sessions, we have videos on them already, and we'll try to make sure that we send you the links to them as we see that there's a need for those topics to be covered again. Can we have a clue? Okay, let's do one of them. This one is let's see, ENGLISH. So English. So just unscrambling them to form a word. So that one is English. So give the other 3. That should already give you a hint as to what these 4 words have in common. All right. You're on the right path. No, it's one word. The second one is one word. Chinese, okay, all right. I knew it, that you guys will knock this out of the park. Chinese. Okay, all right, that's very correct, Ogechuku. That's very correct. Spanish. Okay, you can see all these are languages. So English, Spanish, Chinese, and German. All right, that's good. So I want to let you guys know we have something special coming up next week, Thursday. Next week, Thursday, we're going to be having a Kahoot competition for you all. We're going to have one for we're going to have one for elementary school, we're going to have one for middle school, and one for high school. They're going to be 3 back to back, and there's going to be an award. The first 2 win, the top 2 in every competition will be going home with a very good award. And so I'm looking forward. Share the word. Let's make it fun. It's going to be Kahoot. We're going to live stream it next week from 1 p.m. Central Standard Time till about 2:30 or 2:45 Central Standard Time. So I look forward to that. I'm looking forward to it. Subscribe. Until you subscribe, you can get reminders. Share your friends. Tell them to subscribe so they can join the competition. Subscribe now. If you haven't subscribed, please go ahead and subscribe. We're going to post information about this on our YouTube channel. We have a community page on our channel now, and so we'll post information about it on the channel, but you will only get to know about it if you subscribe. So if you haven't subscribed, please go ahead and subscribe. Also share with your friends, invite them to subscribe so that they can also enjoy the fun that we're going to be having next week, Thursday. So I thank you all for your time, and always appreciate you guys joining our session. Don't forget, next week, Thursday, is going to be fun. I already really thinking about the questions that we're going to be using for our Kahoot. Is going to be exciting for you all. Invite your friends. Let's have a good time. Let's have fun doing some math, and we will be giving out some awards for real. You guys are going to be excited about the awards that we have to offer. So thank you again for your time. Enjoy the rest of your week, and I look forward to hanging out with you again on Tuesday and Thursday. Tuesday, I may do some work to review some of the types of questions on the Kahoot competition, so you would only know if you join us on Tuesday. And then on Thursday, we're going to have our competition. And thank you again. And you guys have done a great job today. I'm always proud of you. And I'm sure that as you get ready to go back to school, you guys are going to be blazing the trail you're going to be blazing the trail. So have a good one and enjoy your weekend. Be blessed and see you next week. Bye for now.